Good morning. Today we are doing 8.1 day one, probability distributions and expected value. So first, a probability distribution is a description of some chance behavior that consists of two parts. It consists of a list of possible outcomes and the probability that each outcome will happen. So for example, my outcomes for flipping a coin twice are that I could get two heads, one head, or zero heads. And the probability that each of those things happens is there's a 1 out of 4 chance that I can get two heads, a 2 out of 4 chance that I could get one head, and a 1 out of 4 chance that I could get zero heads. A sampling distribution tells us what values the statistic takes in repeated samples from the same population and how often it takes those values. So in the same table where I have two heads, one heads, and zero heads, I repeated this simulation 340 times and I got 84 two heads. I got 171 with one head, and I had 85 where they were both tails or zero heads. A random variable is a numerical value that describes the outcome of a random event. It must be a number, and the answer must be able to be predicted, but unknown. So, is this event a random variable? The amount of money won playing poker. Okay. The answer is going to be a number, and it's going to be able to be predicted. I can predict I'll win $10, but it's really unknown whether or not I'll actually win that $10. So yes, that is a random variable. Event B, the number of minutes in class each day. So let's go through it. If I asked you what are the number of minutes in class, you would say 90 minutes. Okay, so that's known, right? This part right here where it has to be unknown, this is not a random variable because the number of minutes in class each day is known. Therefore, it's not the unknown piece of it, so that's not a random variable. Okay. Expected value is the average of all possible outcomes, each weighted by its probability. So we're going to multiply each possible value by the probability and then add the products. Find the expected values of the game described by the following probability distribution. So in this game, I can lose $2, and the probability that I lose $2 is 9 out of 21. I can break even, i.e., I get $0 back. The probability that that happens is 11 out of 21. And I could win $10, and the chances that I win $10 in my game is 1 out of 21. So what I'm going to do to find the expected value is I'm going to multiply, lose $2. That turned into -2 because -2 means I've lost money. So I take this -2 and I multiply by the 9 over 21. I take away the $0 and I multiply by, that should be, hold on a second, that should be 10. I'll fix it so that it's right when I put it in the Google Classroom. This should be 11 out of 21, not 18. That should be an 11. I need a pen. I need to fix it. I can't leave it like that. Okay, so let's make this an 11. Okay, so, and then $10 times 1 out of 21. So -2 times 9 is where we get the -18. 0 times 11 is 0, so there's nothing over here. And 10 times 1 is 10. So if I add those together, that gives me -8 over 21, or -0.38. So in the long term, I'm expected to lose 38 cents per game that I play. Okay, so now let's toss 3 coins. What's the sample space? I could get heads, 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 tails, 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 heads, heads, tails, tails, heads, heads, tails, heads, tails, heads, tails, heads, heads, tails, or heads, tails, tails. What is the random variable? Okay, the number of heads that I get would be my random variable. So the probability distribution, we're going to list out my possibilities for my random variable. The random variable is the number of heads. So I could get 0 heads right here. I could get 1 heads. I could get 2 heads, or I can get 3 heads. And now I'm going to look for the probabilities. Well, 0 heads is this option right here. Okay, so there's 1 out of 8 total options. And then One head are these three options right here. There's one head in those three. So there would be 3 out of 8 options. Okay. Two heads are these 3 options. So there's 3 out of 8. And lastly, we could have all 3 heads, which is this option right here. And there's only one of them, so the probability is 1 out of 8. Now, probability rules still apply. This has to add to 8 over 8 or 1 in order for this to be a valid probability distribution. So 3 plus 1 plus 3 plus 1 is 8. Divided by 8 is equal to 1. So this is a valid probability distribution. So what's the expected value? Well, the expected value, I'm going to take the 0 and multiply by 1/8. I'm going to take the 1 and multiply by 3/8. The 2 and multiply by 3/8. The 3 and multiply by 1/8. Okay, so let's see. 0 times 1 is 0. 1 times 3 gives me 3. 2 times 3 is 6. 3 times 1 is 3. And now add these, the denominators are all the same, so add the numerators. So that's going to give me 12 over 8, which is 1.5. So the average number of heads that we expect to get in the long run is 1.5 heads. Okay, so 8.1 day 1 practice problems is a Google Slides. You need to determine whether or not the variable given is a random variable and determine whether the probability distribution is valid. Go ahead and get that done and turn it in, and I will see you for the next lesson. Thank you.